Hi everyone. Before we get into the second half of chapter 4, I wanted to do a quick review of this idea of the factorial, since we'll be using it for everything else in this chapter. So, a review of factorials, and I've got an example there. This is 5 factorial, so the notation for a factorial is an exclamation point, which is kind of strange. So you would read 5 exclamation point as 5 factorial. Now, what is this? What are we supposed to calculate here? So here's the idea. 5 factorial, we're going to start with 5 and we're going to multiply by all of the whole numbers down to 1. So for 5 factorial, we take 5 times 4 times 3 times 2 times 1. Multiply all of those, and that's what 5 factorial will equal. In this case, 5 times 4 times 3 times 2 times 1 would come out to be 120. So now the way that we'll see them, usually they won't just be kind of on their own like that, but we'll see these things involved in fractions. So here's a more difficult example. And it's kind of, I'll point to what I've got here in a second. So what if we were working with 10 factorial divided by 8 factorial? We'll see things like this coming up very soon. So one way to think of it would be like, okay, 10 factorial, well, that's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's all being divided by 8 factorial. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now I could go and multiply all of these out separately and then divide them if I really wanted to, but I don't have to go through nearly as much work as that. Because you notice if we've got this division, well, then the 8s would cancel out, right? And the 7s would cancel. All these numbers would cancel, and we don't have to multiply each one of these out separately. We can just look at the cancellation and realize, oh, well, the only thing that doesn't cancel is 10 times 9. And so all I have to do is 10 times 9, and I've got what this thing equals, 90. I highly recommend doing it this way. By the way, a number like this numerator, even the denominator, but try that on your calculator. There, I forget exactly for 10 factorial, there may not be enough space in your calculator to tell you what that number actually is. It might be too big for your calculator's screen to hold. And if 10 factorial does fit, something like 20 factorial would definitely not. Even if 10 factorial did, but I'm not even sure about 10 factorial. So don't do it that way. Don't multiply these out separately. Think of how they cancel out and just do the 10 times 9. Okay, let's try one more. And now this one, the numbers are getting bigger. So let me show you even a different way of doing it. What if we had 25? Let me cover this up just for a moment. I'm like giving the answer away. Oh, okay, well, that's all right. What if we had 25 factorial over 24 factorial? You don't want to even have to write these out the way we did 10 and 8 a moment ago. I don't want to have to write 25 times 24 times 23. Okay, but we don't have to. Think of it like this. 25 factorial is 25 times 24 factorial. Right, think about that for a second. Because what is 24 factorial? 24 times 23 times 22 times 21 all the way down to 1. And so 25 factorial would just have a 25 sitting in front of that. So think of 25 factorial as 25 times 24 factorial. And then keep this one the same, and guess what? Boom, those cancel out. And those are gone. All we've got is 25. Right? We want to be very strategic about how we simplify these. We could have even thought of the last example this way, right? If I kind of do it again over here, think of 10 factorial as 10 times 9 times 8 factorial. And then just leave the 8 factorial down there. I mean, wouldn't this be true? What do we have up here? 10 times 9, and then the rest of this that canceled was 8 factorial. And of course, we have the 8 factorial here. And we could cancel right like that. We don't have to necessarily write out everything, and we get the 90. Even better in this case, cancel right there, and that simplifies to just 25. Okay, so we're going to be practicing more of these very, very soon. A couple things we need to note. The simplest cases sometimes are tricky. So what about 1 factorial? And we will even come across 0 factorial. So 1 factorial, well, this makes sense, right? If you're always multiplying until you get down to 1, then 1 factorial would simply it would just be itself, right? It would just be 1. So we'll keep that in mind. Also, 0 factorial. Now, 0 factorial does not make sense because, you know, any factorial are always counting down to 1. You stop before you get to 0. However, we want to have an answer to 0 factorial, and so we say it just equals 1. This is a special case. This doesn't fit the pattern of the rest of the factorials. We say 0 factorial equals 1 by definition. So it breaks the pattern of the other factorials. We're just going to say it always equals 1. The truth is, if 0 factorial did not equal 1, then all of math as we know it would come crashing down. So we're just going to go ahead and say that's true. Okay, that does it for this video. We'll pick it up in the next.